the population of a village increases continuously at the rate proportional to the number of inhabitants present at any time. If the population of the village was 20,000 in 1999 and 25,000 in the year 2004, what will be the population of the village be in 2009? Do you think the solution to this type of problem can be solved using simple linear equations? You are correct if your answer is no. Why? Here, the highlighting information is the population increases continuously at the rate proportional to the number of inhabitants present at any time. If we try to frame an equation, we get dy by dt proportional to ky, where y represents the population. Now, changing the proportionality sign, we get dy by dt is equal to k into y, or dy by dt minus ky is equal to 0. The equation which you see here is unlike other equations, and the equations of this form is called differential equations. These equations arise in a variety of applications. Hence, understanding differential equations is of prime importance. Let's get a deeper insight into this. We can define differential equations as equation involving derivatives of the dependent variable with respect to the independent variable. Mathematically, we can represent it as dy by dx is equal to g of x, where y is equal to f of x. Where what is y? Y is the dependent variable and x is the independent variable. Alright? Again, differential equations are of two types: ordinary differential equation and partial differential equation. Ordinary differential equation. What is ordinary differential equation? It is one which involves derivatives with respect to only one variable, while the partial differential equations involves derivatives with respect to more than one independent variable. However, we will confine ourselves to the study of ordinary differential equation. Now, let's use our brains to note down the following notations for derivatives. First order derivative. It is represented by dy by dx, which is equal to y dash. A single dash is used. Second order derivative. It is represented by d square y by dx square. It's represented by another way y2 dash. Third order derivative. It is represented by d cube y by dx cube. That is equal to y3 dash. Now, how the higher order derivative will be represented? Which is equal to d raised to n y dx raised to n, or y subscript n. Next, we will discuss another important aspect of differential equation, that is order and degree of differential equation. Now, when a differential equation is given, one must be able to identify the order and degree of a differential equation. First, we will discuss the order of a differential equations. The order of a differential equation is defined as the order of the highest order derivative of the dependent variable with respect to the independent variable involved in that particular given differential equation. For example, d cube y by dx cube plus 2x d square y by dx square the whole square minus dy by dx plus y is equal to 0. So, in this question, the higher order derivative is d cube y by dx cube. So, order of the differential equation is 3. Now, consider this equation: d square y by dx square the whole raised to 4 plus y is equal to 0. Here, the highest order derivative in this question is d square y by dx square. So, it is a second order derivative. So, the order of the differential equation is 2. Now, what will be the degree of these differential equations? Degree is the highest power, that is the positive integral index of the highest order derivative involved in the given differential equation. So in the above examples, d cube y by dx cube plus 2x d square y by dx square the whole square minus dy by dx plus y is equal to 0. Here the highest order derivative is nothing but d cube y by dx cube. Now what is the power? Here it is 1. So the degree of this differential equation will be 1. Now in the second example, d square y by dx square the whole raised to 4 plus y is equal to 0. Here the highest order derivative is d square y by dx square. Alright. Now what is the degree? Degree is here 4. So we can say degree of this differential equation is nothing but it's 4. Also you might have noted that order and degree of a differential equation are always positive integers. Take these examples. D square y by dx square the whole raised to 2 plus cos of dy by dx is equal to 0. Another equation, y3 dash plus y2 dash plus e raised to y dash is equal to 0. In these two examples, the differential equations are not polynomial equation in its derivatives. Hence, their degree cannot be defined. So, the necessary and essential condition to find the degree of a differential equation is that they must be polynomial equations in derivatives. So, we learn to identify differential equation, its order and degree. Next, we move on to find the solutions of a differential equation. Differential equation gives two types of solutions. One is general solution. What is a general solution? General solution is a solution which contains arbitrary constants. And the other is particular solution. What is particular solution? It is a solution which is free from arbitrary constants. More clearly, particular solution is obtained from general solution by giving some particular values to the arbitrary constants. Let's discuss one problem. Verify that the given function y is equal to e raised to x plus 1 is a solution of the corresponding differential equation y2 dash minus y dash is equal to 0. Let's see the solution. Given y is equal to e raised to x plus 1. Now, what is the differential equation? Differential equation is y2 dash minus y dash is equal to 0. So, we need to find the second order derivative and the first order derivative. So, we'll find one by one. dy by dx equal to y dash is equal to taking the derivative of y. E raised to x plus 1, we get e raised to x. Now, d square y by dx square is equal to derivative of the first derivative. So, we get y2 dash is equal to e raised to x. Now, substitute y2 dash and y dash in the differential equation. So, we get e raised to x minus e raised to x is equal to 0. So, LHS is equal to RHS, hence verified. Therefore, the given function is a solution of the differential equation. Now, we have verified whether the given function is a solution of the differential equation. Now, if a general solution is given, how can we formulate a differential equation? Let's discuss this in the coming video. Now, let's summarize what we have covered in this section.
Manorama Horizon. Learning made simple.